Hello, I want to start this video by apologising for being such a miserable bastard at the beginning of this video. I don't know why. I'm very happy with how it ended up being, but I guess I wasn't very optimistic at the beginning. You'll see what I mean, but please do stick with me. I do get a little bit more cheerful throughout the video, I think. Anyway, here is what I'll be making, or explaining in today's video. There we go. It does occasionally hitch, but it does work. There we go. Anyway, so that's the end product. I hope you enjoy the video. It is a bit long. If you stay to the end, there are some funny bits. Well, I think there's one funny bit. The other two, if you want to skip to it working, just go straight to the very end of the video. Anyway, on with the tutorial slash walkthrough thing, whatever this is. Okay, I'm assuming I've already done an intro for this video. So that means you've probably seen the finished product, or I don't know yet. I've literally just started doing duct tape and cling film. So how I've made these templates is relatively simple. You kind of just get your main original piece. I'll show you what mine was. I think you can probably get something like this quite cheap now. At the time I got this for a birthday present, I think it was about £50. It's not as big as that. It's closer to my actual head size. I cling film wrapped it and then duct tape wrapped it, and then it means you can draw your pattern on, which is what I've done here. And then you just cut it off, cut all the pieces down. I've already taken the chunks at the back, which I probably shouldn't have done before starting the video, or before recording, because I should have shown you the entire thing. You can also see that if I replace it back on, I've moved some key areas. So these bits here, I've moved up, like these rings. This helmet in particular, it has a different shape to it. I've adjusted where this line sits further down the facial slit. I've adjusted the length and the height of these, and more obviously the eyes. The eyes sit a lot lower. When you look at it, it's not all that low because you've got these slits here. So all the blue area doesn't matter, it's only the black. And it's only, when you actually look at it, it's about 5mm lower than it originally was. And I've checked it, and it does line up with my eyes. So it's gonna look really stupid, but you can see there it does line up with my pupils. It also lines up really well with my mouth, actually, and my chin. So we've got the base done. It will be quite a nice fitted thing. This looks like that Marvel Legends figure that came out a while ago of the Peter Parker and Spider-Man head that was mashed into one. But yeah, if you look at it, you can actually see that my pupil, and I can see the line. I don't know if you can see through. No, you probably can't. Because it's lighting on the other side of the camera, I can see this eye slit through the other side, and when I put it on, it's directly in front of my eyeball. And if you look, it sits just in front of my pupil. So I will be able to see perfectly out of this. I'm going to cut it down, transfer it all onto the foam, and then glue it together and assemble it. These templates I will upload photos onto Google Drive so they can be downloaded, printed, and I'll try and get the scaling right. If I can, I'll draw them out so they're individual pieces rather than the duct tape photos, but I might not have time to do that. Regardless, these templates will be up for free. I don't like charging for templates, because myself as a cosplay starter a few years ago, when I wanted like a dome shape or anything, you had to pay for template, and it was ridiculous. It was like £5 just for a file, which I understand work goes into it, but me personally, when it's a 3D file, I think it's quite different because you can mass produce stuff like that. When it's something like a dome template that I worked out myself in about 10 minutes, and professional people will sell them, I don't see it being worth selling templates for that much, because you're kind of just taking off of something that could be uploaded for free. And then there's a free one online anyway, but basically these will be out for free, as well as the tutorial, and whatever templates I make after this, I'm not sure how many will be. If I make any 3D files for this, they will also be released for free use. Anyway, on to the next bit. Okay, as you can probably tell, I've finished the actual foam build now. I do have all the templates finished, they're ready, I can upload them at some point. They are currently just duct tape. If I get time to outline them and turn them into a drawing, I will, but it's most likely they'll be uploaded as a photo of the duct tape, and they'll be scaled correctly, so you just have to cut them out, but it will probably be duct tape and you just cut that pattern out. I did run into 1 or 2 issues. I forgot to like do all this bit in templating, and there's a little bit that I had to add on the side of this so it extends to my cheek. The rest of it I think is correct. Oh, I haven't done the chin bit. There's meant to be a little cut in at the chin. I'll add that in afterwards. You can probably see if I had to sweep my hair into curtains as well. My hair's too long at the moment, so if I put the mask on, it goes in my eyes and then I can't see, and it actually comes out of the eye holes. So hopefully I'll have a haircut by the time I get around to Comic-Con. But if you can't see already, this is aluminium wire that runs the entire way up. It goes all the way around the outside of the face. And I've done it on the inside of the mask as well. That just holds everything in place, so essentially it lines up properly. Because I've done it out of thinner foam, I think it's 5mm. Okay, it looks like it's 3mm. So it's a little bit too thin for this kind of stuff, but you know, if you reinforce it, it should be fine. There's obviously no magnets or anything in it yet, so it's literally just a loose fit. Can't see where I'm walking either. It fits really well together. There is gappage, but it needs to be there because it needs clearance when it moves. The top might need sanding down a bit because it's currently touching and I don't want it to get clipped when I add the servo. The rest of it seems to have a good enough gap. With the servo, I'm hoping it will move up to about here, so I can actually see. That's a good point. I want to test if I can drink or anything in this, because I don't want to have to take the whole costume off at the convention. Okay. Okay, so you can drink. It's just a bit of a pain, so maybe get a straw if you're doing an Iron Man costume like that. But yeah, I'll take this off and I'll show you the actual areas that I've gone and added in. Okay, so my hair's still kind of in the curtains look, but it will do for now. So a rotary tool is really important if you're doing any sanding and you want to get, ideally, a handheld rotary tool. I've got one of these. It's the, is it Ryobi? I don't actually know what it is because I peeled the label off at some point. It's just a little USB charging one. Nice and cheap. I think it's about 20 quid off Amazon. So yeah, they're probably cheaper in the US as well. But it comes with all different bits. You can see I've gone and done all these rivets in here. I did mess up the first one that I tried. It's meant to be 10 little holes and I ended up doing 12. And I noticed afterwards when I counted them. But I've done it on both sides, as equally spaced as possible. And then I've also used it to sand down. I need to try and fix this seam if I can. I had an error and I had to cut straight up. But you can see I've sanded down all of this seam here and the one that runs across the top. I've then used the same rotary tool to get this bolt hole and the one on the other side. I've also rounded off some edges, like the cheeks here. This line I might need to fix because it's actually meant to curve back to here. I'm tempted to leave it because it makes it more unique than just making it the exact same. However, I'm a stickler for accuracy and it's kind of bothering me that I've not got it. Like I said, I need to go in and add the little chin cut at the bottom as well. This piece was a bit of a pain because you can see there's another layer in there. There's another layer of foam in there to get an actual curve to it. And then I didn't realise until I was looking at my reference images, the light comes from a hole at the back as opposed to this entire section lighting up. Which, if you remember my previous version, I made the entire semicircle there light up, which makes more sense because I suppose it'd be a headlight because it's a deep dive suit. Same as the cheeks, it's probably so you can see what he's doing. But I think my favourite part of the bolts that I've done this one, you can see they actually fade inwards, which is accurate to the reference images I could find. And you can see these ones are holes that essentially drilled from straight on. You can see it's actually got depth on one side of it and not the other. So I need to add a bolt into that to make it look correct. I'll do the same for all the other bolt holes. But yeah, this is where I'm at. I'm gonna go and do the circuit board, which I'm not gonna show the full video of. I might do it in a separate video to show how I motorized it. There will be a link to the guide that I used to rig this servo, and I'll explain what edits I've made to the circuit board, because I needed longer wiring and a slightly different setup, but I'll explain that when I get around to finishing it. But that'll do for this part of the video. Trying to work out what else I need to do now, but I think it is just the circuit board. I've got some 3D printing to do to hold the wires and everything in place, and the LED lights, but once this is painted I'll come back and I'll show it. And I'll be using Pladflex paint, which is my first go, and quite possibly an airbrush, which is brand new. I haven't even taken it out of the box yet, so we'll see how it goes. Okay, as you can see, it's probably quite obvious that I've painted it all. I've added the guiding rail in, so that's what's attaching it at the top here. I haven't done the servo yet. I've only just had the circuit board arrive, like my second backup one, so I will go and do the circuit board I think later today, and then I'll 3D design all of the movement arms that are going to connect from here to probably just above where this bolt is. If I do look tired or not very well, I had a massive migraine yesterday, so while I was meant to get this video finished maybe a day earlier than it is, it'll probably be a few more days by the time I mess anything else up. But I'm currently a day behind, basically, and that's why I don't look very well. However, it closes really well, so very happy with that. I've also managed to get a haircut and not styled it at all because I've just woken up. But yeah, it seems to be working really well. This is the Pladflex paint. Not the colour I meant for it to be. I mixed too much green in with my blue, so I'm waiting for more blue to arrive. So yeah, this will be a different shade of blue by the time you next see it, I would think. But trying to go for a bit of a brushed metal kind of look to it, and I've tried to get that swirl in the side of the ears as if it's been turned on a lathe, and it's starting to get there. It needs another coat of airbrush over the top of it. But yeah, I'm really happy with the way this fits together as well. Obviously there are gaps. I might be able to fix those, but I don't want to tamper with it too much, because at the moment it has like the perfect amount of clearance and it shuts really nicely. I also want it to be a little bit breathable so that I can actually get some cold air in. Put my glasses back on so I don't have migraine. But yeah, really happy with all the way the seam lines have shown up on this. There's the seam lines showing up in the cheek as well, which is a bit of a pain because they're not meant to be there. But you know, all things considered, I'm very happy with this. I'll start my work on the 3D file and hopefully get that printed and all the electronics put in, which will be hopefully a nice experience and not a lot of stress. If you are wondering what this support rail is, it's a piece of brass that I bent. I believe it's 3mm diameter, and then those are actually just Jubilee, the Platinum Jubilee straws from Marks and Spencer's that I cut up to hold it in place. But yeah, I guess I'll come back when it's repainted and I've done the electronics and the servo. I'll show you the circuit board before I fit it actually. Okay, it's been a week since I recorded the last part of this video. There's also been multiple versions of getting this motor to work. Also did all the lights, which are much easier than your basic circuitry. Battery packs with switches on, hooked up to the LEDs, no big deal. I won't be explaining that. I didn't end up using a circuit board at all. I didn't build my own. Well, I did. I built my own. I bought one and then edited that one as well to all the instructions I could find online. Could not get it to work for the life of me. Even programmed a circuit board, which is this one here, which is the Pickaxe Proto board. whatever it's called, and it would download, but it wouldn't activate, and I couldn't work out why. So I bought another one, and it's still in the packaging. So I decided just to kind of mint a servo in the end on my own. It does bother me that it sticks on the chin, but I don't have a whole lot of options apart from that. So it's fairly hidden. You probably won't notice it quite as much at Comic Con, or I hope you won't, because I'm not editing it again. Got two buttons here. Basically, the way this works is normally your servo will have this wire coming off of it, which you can see has a black for the negative, a red for the positive, and a white for the signal. What I've done to mine is I have opened it up. I took the screws off the bottom here, opened it up, cut the signal that goes to, cut all three wires that connect to the circuit board, cut the wires off that attach to the motor terminals, and wired the black and red, the positive negative, directly to the servo instead, so it goes straight to the motor. And then these lead off into buttons, and each one of these will veer off into a battery pack, and then the battery packs will be reversed. So I've got one that has positive and negative leading into the black and red, and then the other one is reversed, so it puts a different current through the servo, if that makes sense, because the way a motor works is you can run a current through one way, so you can do positive and negative and it will turn clockwise, or you can run negative and positive and it will run anti-clockwise, which is what I've done here. I've just got that button activated here, so one allows a positive current through. I mean, both allow positive current through, but through different terminals, basically. So this allows it through the right, this allows it through the left terminal, and that will make the servo turn in two opposite directions. So if I pull this one here, I need to hold it a certain way so that it actually opens. So if I run it through this way, you can see that opens there, and then it's quite difficult to actually keep on camera doing this. And I've got the other one as well, which probably won't work now that it's on camera because it's been a bit buggy because I broke it while I was trying to solder it together. Yeah, there we go. It catches when you kind of squeeze the top ends of it together. But yeah, it works perfectly fine. I would assume when it's on the head, it works perfectly fine when it's sat down. There'll be a clip of that coming up after this section. So if you're done now, that's all you wanted to know, fast forward to the clip. But yeah, this is everything. You can see I've got it wired up to, each one leads to one of these battery packs on either side. I will be covering it, covering each battery pack with a bit of foam that will have magnets or something so I can take it off to change batteries. But I don't want to like risk having battery acid or something leak on my head while I'm wearing it, or having them heat up, which can happen if wires cross. If you create a loop with a battery pack, the batteries will heat up and you can burn your hand, as I found out in year 4 of school, I think. But yeah, this works really well. I'm very happy with it. It holds itself up, and then the close button works as well. The close doesn't work perfectly. I've got a little bit of sanding to do, or I might just leave it, because it does close over time, it just doesn't close immediately. Like you can see there, it's slowly sinking back, but it does close all the way. It just takes maybe a second more than I would like it to. See, I'm finished. Hope you've enjoyed this video. Again, there'll be the clip coming up of it opening and closing afterwards. And there's another blooper of me just not realising it was recording. This new phone does a whole gimmick where you put your hand up, it starts recording, and it recognises me brushing my hair as wanting it to start recording. So there's a clip of me taking a sip of, you'll see it, an interesting experience to realise you're being filmed after you've just recorded the section of the video. If you want more tutorials on how to do this kind of thing with a servo, I believe Frankly Built did something similar. He called it hot wiring a servo. There'll be a link to that video if you want to know how to do the proto board method. I will leave a link to James Bruton from X Robots, and then whatever other one I had where I was going to try and build it myself, there'll be a link to that as well. If you want to try them, you're welcome to. I couldn't personally get them to work, but that could just be me, because I don't always well, to be fair, I think the Pickaxe Proto board, I messed up the soldering, so that might be why. But yeah, anyway, here's the other two clips and the links for anything else that are in the description. Oh. There we go. Of course it won't work for the beginning of the video.